Hi there, so today we are going to learn how to create a general formula for your patterns question. Now this is applicable for upper primary students as well as secondary school students. Through a general formula, you will be able to work beyond the patterns that you are provided in your question. Take for instance, if you are asked to find the total number of matchsticks that is in this question over here in pattern number 205. Now, it will be very hard for you to work one by one till pattern 205. So that is where general formula is important. There are multiple ways for us to work out a general formula, but I will be sharing with you today the most straightforward one. So here are the steps. First, find the common difference in your pattern question. Let me apply it to our question and get you to understand what is a common difference. From pattern 1 to 2 in our question number 1, we observe that there is an increment of 3 matchsticks. From pattern number 2 to pattern number 3, we can observe that there is another increment of 3 matchsticks. What we are finding here is a difference between each of these patterns. And what we have observed is that there is a common difference of 3. So this is what we refer to as a common difference. Now in our question 1, our common difference is that of 3. Now let's try question 2 as well. From pattern 1 to pattern 2, we observe that there's increment of 2 shaded triangles. While from pattern 2 to 3, there's an increment of 3 shaded triangles, followed by 3 to 4, it will be 4 shaded triangles. Now what do we observe here? At this level, which we call it a level 1 difference, we do not observe a common difference yet. While in question number 1, we did observe our common difference at the first level. When you did not find your common difference in the first level, you proceed on to find the difference between the differences that you have found in your question. We can see that there's an increment of 1, and there's an increment of 1 as well. Here, we have found our common difference, and this common difference appear to be in level 2. This brings us to the second step, where we identify what type of pattern we are looking at. When you find a common difference at level 1, that would be known as a linear pattern. While if you find a common difference at level 2, we call this a quadratic pattern. It is important for us to identify the type of pattern that we are looking at so as to enable us in step 3 to apply the right pattern formula to our question. Let us start with a linear pattern. In a linear pattern, the formula of our interest would be Tn is equals to Dn plus C, where D refers to our common difference, N refers to the pattern number, which would be like 1, 2, 3, so on and so forth. While C refers to a constant which may or may not exist. We will cover that in detail later on. While Tn refers to the actual total number of items in each pattern. Like in this question, it would be the number of sticks in each of the pattern, such as 5 sticks, 8 sticks, 11 sticks, so on and so forth. It is through this pattern formula that we are able to create our general formula. And this has to be done so in parts. Let me now guide you through. The first part for us to look at would be Tn is equals to Dn. Recalling that earlier on, we have found our common difference to be that of 3. As such, writing out our first part of the formula, it will be Tn is equals to 3n. Once done, we will have to validate whether this formula would work out to the actual total number of sticks in each of these patterns. So that is where we use the values of each of the pattern. For instance, n being 1, that's term number 1. The total number of sticks using this formula work out to be 3 times 1 being 3 sticks. In term number 2, we will have 3 times 2 giving us 6 sticks, and n equals to 3, which is pattern number 3, it gives us 3 times 3, which is 9 sticks in total. From here, we can compare the total number of sticks in each of these patterns against that of the actual total sticks in each of the patterns. And we can see a difference between our total from our formula of Tn equals to 3 as compared to that of the actual total. And this tells us that we have to move on to find the outstanding constant, represented by this second part of the formula. This constant can be found through observing the difference between the total that we have found here in each pattern and the actual total. We can observe in our question here, if we were to add 2 to each of the total for the respective patterns, they will add up and tally with the actual total. Hence here we have found our constant, which is an addition of 2. And there we go. We have a general formula which is Tn equals to 3n plus 2. Do feel free to verify this general formula on your own, and let's move on to quadratic pattern. When it comes to creating a general formula for quadratic pattern, pretty much every steps that we have followed in linear pattern is applicable here. Now with a slight difference, which is in the formula that we are using. The formula of our interest would be Tn is equals to d sub 2 over 2 n square plus d sub 1 n plus c. And the terms Tn, n as well as c refers to the same thing that we have seen in linear pattern. The slight difference would be in the d, where d sub 2 refers to the common difference at level 2, and d sub 1 refers to the common difference between actual total and pattern formula. Now when we are creating the general formula, it is similar to what we have done in linear pattern. We will have to look at it in parts. The first part that we look at would be Tn is equals to d sub 2 over 2 n square. Do recall that what we have found earlier on, common difference at level 2, which is 1. Therefore, we can write our formula here as Tn is equals to 1 over 2, where d2 refers to the common difference 1. And completing it will give us half n square. Now for easier reference and calculation, you may like to keep the fraction as a decimal instead, which is 0.5 n square. Similar to what we have done in linear pattern, we are gonna do a validation to look at whether the total found using this formula will tally with the actual total in each of these patterns. So let's do a quick one, and we have T1, which is pattern number 1. We have 0.5 times 1 square, giving us 0.5. T2 is equals to 0.5 times 2 square, giving us 2. For pattern number 3, it will be 0.5 times 3 square equals to 4.5. And pattern number 4, we have 0.5 times 4 square, which gives us 8. Now let's write down our actual total for an easier reference here. We know that the actual total for pattern number 1, it's 1, and for pattern number 2, it's 3. For pattern number 3, it is 6, and pattern number 4 is 10. We can easily spot that there is a difference between our total, which was found using our formula, versus that in the actual total. This tells us that we have to move on to the next term, which is d sub 1n. Do take note that d1 in d sub 1n refers to the common difference between actual total and the pattern formula. So our current pattern formula total is here, and our actual total is here. To find the value of d sub 1, we will have to find the difference between the actual total and the total that we have found using our formula, level by level, till we find a common difference. This is in the same fashion as what we did earlier on to find the common difference between patterns in our question. So at the first level of difference between our actual total and our total here, in pattern number 1, we can see that an increment of 0.5 will give us 1. For pattern 2, moving from 2 to 3, that would be an increment of 1. And for pattern 3, from 4.5 to 6, it is an increment of 1.5. And last but not least, for pattern 4, an increment of 2 from 8 to 10. At this level of difference, we do not see a constant difference. As such, we will have to move on to find the difference between the differences. And we can see that from 0.5 to 1, it is an increment of 0.5. And from 1 to 1.5, it is an increment of 0.5 as well. And last but not least, from 1.5 to 2 is also an increment of 0.5. And voila, we have found a constant difference. This tells us that d sub 1 value would be 0.5. With that, we will rewrite our general formula as follows. En is equals to 0.5n square plus 0.5n. Once again, we will have to validate whether this formula gives us a total in each pattern that tallies with the actual total. And that would be 0.5 times 1 square plus 0.5 times 1, which gives us 1. P2 equivalent to 0.5 times 2 square plus 0.5 times 2 equals to 3. And pattern number 3, 0.5 times 3 square plus 0.5 times 3 equals to 6. We have P4 equals to 0.5 times 4 square plus 0.5 4, giving us 10. So as you can see, the total that we found using this general formula is exactly the same as the actual total in each of our pattern in the question. When this is the case, we are done with our general formula, and it also tells us here that we do not need to proceed on to look for the constant. I believe many of you may be thinking, oh my, what if my total in this part over here did not tally with the actual total? Now the answer is very simple. It would mean that you will have to proceed on to find your last term, which is the constant. And the way to go about doing this is to find the difference between the total that you have found in each of these patterns using your general formula that you've created with the actual total. Find the difference between the two of them and look for the common difference, and that will naturally become your C over here. Once that's done, you write your entire general formula, and there you go. Alright, now we have come to the end of this video. I hope you enjoyed this tutorial and found it helpful. So if you did, please don't forget to give this video a thumbs up and subscribe to our channel for more of our tutorials. Thank you for watching, and I'll see you on the next video. This is Bowen. Make it count. Ciao.